Hi everyone, this is the last of the Analyzing the Data lectures that I will be doing. In this week's videos, we'll be dealing with testing for interdependence, which is related to chapter 16 of your textbook. So in testing for interdependence, what we're looking for is ways in which our data and which our variables can be grouped together in order to explain how things, stuff, feelings, people can be understood as groups. This is especially important if we want to summarize our constructs, and also if we want to build in marketing target markets. Essentially, if we do cluster analysis, is essential in terms of developing potential target markets. So see if I get this to work. Alright, so in terms of the tests that I'll show in these videos, I'll show factor analysis, which is where we are grouping our variables, and then how we use those groups of variables in a multiple regression. And then I'll show cluster analysis, which is how we group objects or people or respondents into groups, i.e. potential target markets, and then how we can use those clusters combined with discriminant analysis in order to be able to predict which group people are likely to belong to. I'll also add an extra video that relates to structural equation modeling. This is not something that I expect you to be able to do, but it's an extremely powerful tool in understanding the causative relationships between variables when what you are wanting to do is looking at multiple independent variables, effects on multiple dependent variables. So this week's lectures again relate to establishing the reliability and validity of the data that you've collected, because we need to apply the correct tests in the right situations. And it is also about integrating your quantitative data in order to find solutions to the marketing problem. So first things first, the factor analysis. So factor analysis looks at is a statistical technique to condense the information contained in a large number of variables into a number of information pockets. That's a long way of saying basically that in our surveys we often have multiple items or multiple questions that are trying to test for the same underlying theoretical construct. So in the previous lecture I have talked about the theory of planned behavior and how in operationalizing that theory you have items for each of the constructs that are included in that theory. For example, I showed you at least 3 questions that you would ask to measure someone's perceived behavioral control. So in order to determine whether those 3 items are actually measuring perceived behavioral control, we need to run what's called a factor analysis to see whether those items measure the same thing. Because if they're measuring the same thing, they should co-vary together. So there should be covariation between those items if they are measuring the same thing. So some of the assumptions in running a factor analysis is that we need a sufficient sample size of between at least 5 to 10 respondents per variable. So for example, in the perceived behavioral control example, if we had 3 items measuring perceived behavioral control, we would need at least 15 respondents in the sample to be able to run an effective factor analysis. Preferably we'd want 30 people in the sample in order to be able to run the factor analysis. We need reliable correlations. Missing data is very bad for factor analysis. So if you need to run a factor analysis, you will need to replace the missing values following the SPSS and PSPP procedures. We are assuming normality, so that that the variables are normally distributed, and that multicollinearity is very bad in this case. So there are two different types of factor analysis. What we're going to do is an exploratory factor analysis. Basically, it's used to explore the dimensions of multi-item measures of a theoretical construct. Essentially, you put in all the items that you're interested in. The software calculates the number of factors on which those items load. And if you are expecting it to be one construct, then hopefully the exploratory factor analysis will load all of your items onto one factor. So the important thing as I go through is to understand that a factor is the same as a construct. The other type of factor analysis is confirmatory factor analysis. We're not going to do this type of factor analysis because it is much more involved in the structural equation modeling type of tests. And essentially here in this one, you know how many factors you need, and you know which items fit within each factor, and you are simply testing to confirm that your item loads on your expected factor. So the analysis procedure for factor analysis is here on the right. I'm going to go over to SPSS to demonstrate this now. Again, I am using the Delhi Depot data set in order to demonstrate these techniques, but if you want to use your actual project data, there's nothing to stop you there. So for a factor analysis, the procedure is analyze, so the procedure is to go analyze dimension reduction, which is on the list here, and then we say factor. And the variables of interest here are x1 to x6. So we select all of those and we put that into the variables box. We then go to descriptives and we click univariate descriptives and unclick initial solution, and we say continue. We then go to extraction and click unrotated factors solution. Unclick that and say continue. And then we go to rotation and we select Varimax and continue. And options, this just makes it easier to read the output. We click sorted by size and suppress small coefficients, and I'm going to set absolute values so it doesn't show me anything that's less than 0.3. Generally we say that any loading that is less than 0.3 is a low loading and we do not consider that output. And I select continue and I say OK. So here is the output that SPSS produces, but I'm going to look at my slides so I can show you how to analyze the output effectively. So here is the output and the order in which we consider things. So within the descriptive statistics, we need to check the variables that make sure that they're all entered correctly and that the means are consistent with our other descriptive statistics that we have. Then we need to look at the rotated component matrix table. So we need to check factor loadings of each variable. So in this table, if we hadn't suppressed low means, there would be a lot of extra numbers in these empty spots here. So for each variable should load on one factor. So SPSS calls a factor a component, and we see that in our exploratory factor analysis we have two different factors. So x3, x6 and x1 are clearly only loading on factor 1. x4 and x5 are clearly only loading on factor 2. However, we do have an issue with x2, competitive prices, loading across two factors. So what we can say is that we have two factors, and I can name the variables or name the factors based on the variables that are included within each factor. So factor 1 includes competitive employees, fast service and friendly employees. So I think these items relate to a construct that I am calling service quality. X4 and X5 seem to relate to food because one's excellent food quality and the other one is wide variety of food. So I'm going to call this second factor food quality. I have chosen to remove item X2 from these factors. So if I'm going to use these factors in further analysis, I will not be including X2 within those factors. Then we need to check the percentage of variance explained. Are both factors actually useful? So this is this column on the end, or percentage of variance. It doesn't. So if you look at the percentage of variance explained, we have factor 1 explaining nearly 37%, and factor 2 explaining 32%. So they're both relatively equal in terms of the variance they're both explaining. So the assumption is that they are both useful in explaining variance of the construct as an overall item. So how do we then use factor analysis in these factors in further analysis? Well, we can use these factors in doing a multiple regression, where these factors become independent variables for testing their effects on some other dependent variable. So we then need to compute a mean score for each of these new factors, which will then become our new independent variable. We have done this in class before, but I'm just going to reiterate this process in a video, because why not? So I need to go to my Delhi Depot data again, and I go to transform compute means. For some reason it's come on the wrong screen. So I'm computing a mean, so my code that I'm going to use is mean, and I'm creating a mean for service quality, which I'm going to call servQual. I can make a label of mean service quality factor, and I hit continue. That's optional. Then I say in my numeric expression it's the mean, open brackets. So the first item I'm including is friendly employees. I'm excluding X2 because it didn't it did not load on one factor or another, so I'm excluding it entirely. X3 was included in service quality, and fast service was included in service quality. And I close my brackets and I say OK. And if I go to my data view, my variable view, if I can get my variable view, here is my new service quality factor scores. I then repeat the same process for food quality, and I replace these with X4 and X5, which were my excellent food quality and wide variety of food, and I hit OK. And there is my new items that I can then use in my analysis. So in order to run the regression, we use the SPSS regression procedure for a multiple regression. So the procedure here is the same as what we did last week. We go analyze, pardon me, we go resume, sorry, analyze, oops, gone off the side of the thing, analyze regression, oops, linear, our dependent variables, so we're going to look at the effects of food quality and service quality on satisfaction. So I'm going to move satisfaction to my dependent variable, and I'm going to put my new factors of service quality and food quality. I accidentally didn't change the name of food quality, but never mind. It understands. Into my independent variables box. I then do statistics. I make sure that estimates is selected, model fit is selected, and descriptives and my collinearity diagnostics are selected. I select continue and OK, and I have my multiple regression output. So analyzing these results, the same as for last week, we check for the overall fit of the model and we see that it's significant, and then we go and look to see whether we have a multi-collinearity problem. As we see down here, it is less than 3, so we are okay. And the coefficients for the regression model are both significant in terms of they are both below 0.05 for both service quality and food quality. So we can conclude that both service quality and food quality predict consumer satisfaction level. Oh, there we go. All labeled correctly. So that is our basic analysis of this factor analysis with regression. So the hypothesis was that service quality and food quality positively affect customer satisfaction. So our interpretation is that both service quality and food quality have a significant effect on customer satisfaction to a less than 0.05 level. Thus, we accept the hypothesis that customer satisfaction is positively affected by food and service quality. So if what Deli Depot is trying to achieve is improving customer satisfaction, we would then recommend ways in which they can improve their food and service quality. So in the next video, I'm going to talk about cluster analysis and how that is analyzed, interpreted, and then how we can use it combined with discriminant analysis.